Good morning. I hope you're doing well. As you can probably guess from the thumbnail of this live stream, I have had an interesting week, but I think it's been a good one. Overall, I'm happy with how things have gone. I've definitely learned a lot, and yeah, have a lot to share. So I was debating which order I should present things in today because there's a bit of a journey to take you along that I went through, and then there's also a few other little things which are much better in my opinion. But I decided to take you down the journey first. So come with me and explore what I went through this week. Yes, we are getting comfortable in integration hell. It's a good time. Very hot. So, as may not come as much of a surprise to many of you, the problem is CAN related. Well, was CAN related. So, yeah, the whole starting point of all of this was that I am trying, as you probably remember from last week, I'm trying to get something set up so the Jugglebot can auto level itself. Thank you, Matt. I appreciate the kind words. Yeah, I'm trying to get Jugglebot to go up, figure out what angle it's at, if it's at an angle at all, like an offset angle, and then flatten itself out. Simple, right? We'll see. So, I've been having issues with that, and John Benno, who, as you're all aware, hopefully, is a long-term contributor to the project, he was suggesting that I should record some particular values and just like keep an eye on them throughout this process and make sure that they're not doing anything funny. And I was like, okay, cool, that sounds like a reasonable idea. I started doing that, and in this process, I realized that I was getting unbalanced phases. An error that is called unbalanced phases on two of the ODrives. And for anyone who's unfamiliar with what this means, it's that the motor phase resistances are not balanced. So you have to use, ODrive suggests checking the connections, and these would be, like if we're using this motor, for example, these would be checking the connections between these three motor wires and the ODrive itself. And I'm like, I haven't changed these wires in a long time, and they're pretty solid connections, and there's really not that much that can go wrong with them. Like, it's just a terminal block that you screw into, and then that goes out to barrel connectors, and those barrel connectors have no like load on them at all, and I checked them and they look fine. And then that goes into one of these like MT60, like these triangular plugs, and then to the motor. It's like, there's not really that much there that can go wrong. And I'm like, that seems weird. And it was on two of the ODrives as well. And I'm like, okay, this is odd. I'm gonna have a look at this in the GUI, because the ODrive GUI is really nice. It's very helpful for like seeing what's going on. And I noticed that in the GUI, it was showing that one of those ODrives had this 0.6.9-1 firmware. And I thought, that's weird, because I was under the impression that all of the leg ODrives had just 0.6.9, and that was it. And I'm like, that's strange. I want to make sure that all of the leg ODrives at least have the exact same firmware, because I want them all to be the same, because they're all supposed to be the same. And I was like, okay, cool. I will update the firmware on all of them and just make sure that, just triple check that they're all the same. So I went through the process of putting on new firmware and like restoring the config file and everything so that they're all identical, because I hadn't done that in a long time since I'd like rebuilt everything. And I'm like, okay, let's run through the whole process again, just make sure they're all identical. And at the start of this process, I discovered that there is a new firmware update process, which is actually kind of cool, that ODrive has introduced somewhat recently. And this process involves installing a bootloader code onto the ODrives, so that way you don't need to like flick a manual switch when you want to update the firmware. And you can just send a command. You can even send the command over CAN. You can update the firmware of the device over CAN, which is pretty cool, because that means that once you have, like, if you have your robot fully set up, you don't need to have the USB connection for anything, really. Like, if your CAN system is robust enough, which mine certainly isn't, because I have access to the USB port, so I don't need to do this. But if you wanted to, then you could do everything that you need to do just over CAN, which is really cool. However, something that I didn't really pay enough attention to is the fact that this new bootloader process that you upload onto the ODrives introduces a CAN command, because of course it has to if you're going to do this over CAN, which puts the device into bootloader mode. And that command is 0x1f. And there's also, it turns out, a broadcast ID, which allows you to send a command, a single command, out to all of the ODrives on the bus, which I actually think is a really cool feature. But I didn't really understand what this meant when I saw this in the docs, and I'm like, okay, cool. I thought that was just for doing just this firmware update process. You would send out just this command with the 0x1f, and that's the only purpose of that broadcast ID. But it's not. That broadcast ID can send any command you want. But anyway, yeah, turns out if you do the bit shifting that you need to do that the ODrives do to get the overall arbitration ID. So this is your arbitration ID, which is what the CAN bus actually uses to determine if that message is for this particular node and what that message is. And you want to guess what I was using as one of my messages, specifically for the tilt message? That was my arbitration ID. So once I uploaded this bootloader firmware, this bootloader mode onto the ODrives, every single time I tried to take an inclinometer reading, I would send out this 0x7ff arbitration ID command, and that would instantly put all of the ODrives into bootloader mode. And I was like, what is this weird purple light that these ODrives are making right now? Because I had never put them into bootloader mode before because I never needed to. And I'm used to like green light is good, blue light is like idle, just kind of waiting around, and red light is bad. But what the heck is purple? And after a lot of messing around, I realized that somehow, I didn't realize what the actual problem was, but I realized somehow one of my commands is sending them into bootloader mode. So I went through and like basically stopped my code at different points throughout until I was just working my way through until I realized that it was this tilt ID command. I didn't realize why it was doing this, but I knew that that was the problem. So I was like, okay, cool, I'll just change and not use 7FF anymore, and instead I'll use 7FA. And chaos ensued. I have a nice video here to show you what I was observing. So in this video, one of these legs, the one on the far left, it doesn't move, but that's a separate thing that doesn't really matter. So we can see I make the robot go to a certain position, and then it just waits. And let's just see what happens if we let it wait for a bit. We see, oh, it just wants to go down. It doesn't want to stay up anymore. It just wants to keep slowly, randomly moving its merry way down. Until eventually I cut it off because I'm like, nah, it's going to kill itself if it keeps moving down that way. So that was kind of confusing, and that happened many, many, many times. And I was recording a bunch of charts in the ODrive GUI, and we can see this is a very emblematic chart of what I was noticing. This is what they all looked like pretty much. So I would send a command to move down to, say, the position -2, because negative is elongation for the legs. So I'd tell it to go to position 2, and then it will get to like 1.7-ish. And then after a while, we can see that the IQs slowly go down until eventually at some point, I don't really know when, it just decides at some point to go, oh, I'm gonna take a little step. Boop. And so yeah, on this top chart, if you can't see the words, this top chart is showing the position where the blue and red lines are like where I'm telling it to go to, and the green line is where it actually is. And then on the bottom chart, we can see basically the currents that are going into the motor. And yeah, it just for some reason just decides to step and then step and then step and then step, and then eventually it just gets to the end, and then I cut the process off before it runs itself into the end stop. And this was very, very confusing for me. I had absolutely no idea what was going on. So I asked the guys on ODrive, on the ODrive discourse, and Oscar from ODrive is an absolute legend. He saw this chart and then figured out pretty much instantly what the problem was, which that man, he knows his brushless DC motors. Turns out I was not safe in my choice of arbitration ID once again, because we take this broadcast ID, 0x3f, and we bit shift it the way that ODrive does, And we have this command, which is set pos gain. And so what this meant is that every time I was taking a tilt reading, rather than putting all of the ODrives into bootloader mode like I was before, I am now setting the position gain of all of them. And it turns out that sometimes, in some configurations of the tilt, because the message that I was sending with this arbitration ID had the data of the tilt, like what tilt the robot was currently at. And that data was being interpreted by the ODrives as a position gain. And sometimes, and of course, I didn't want to do this, so all of those values were obviously wrong, but sometimes those values were actually negative. And when that position gain value was negative, I was seeing this weird stepping thing. Oh, such a headache. But finally, I now know what CAN IDs are actually safe. The reason why I originally went for the 7FF ID is because I wanted to get as far away as possible from the normal ODrive IDs, which I'll explain now. So each ODrive, if anyone's doing their own ODrive project, pay attention to this. If anyone's not, I'll go through it pretty quickly. Each ODrive has a block of 32 arbitration IDs. So it has its own node ID, and then it gets bit shifted in this way. So this is like its node ID. It gets sent up by 5 bits, and then we have the command ID. And each, like one ODrive can have up to, well, has available to it 32 commands. These are 32 commands that we can send to it, and something will happen. So they have a block of 32 IDs, starting with whatever its node ID is. And so if we have 7 ODrives, as I do here, and they're numbered 0 through 6, that means we have to stay away from 0x00 up to that value. If I use any arbitration IDs in that range, I will be sending some message to one of the ODrives that it will be interpreting as a message for it, when really I'm intending on that message being for something else. So I need to stay out of that range to make sure that I don't tell my ODrives to set the position gain to be some random negative value. Thankfully, actually, this is actually a really good thing. All of the testing that I have done so far has given those position gain values as being a really small value. And I think that's probably a good thing, because I think if it was a super high value, then I might have had very aggressive movements happening, and that could have been pretty bad. Thankfully, because these values were really small, all of the erroneous movements that the ODrives were making were very small and very slow, so that I could actually see what was going on and notice that there was a problem and be able to stop it before something broke. So I guess that was good. Silver lining, I suppose. So I need to keep out of this range. But we also have the broadcast ID block. And this block is right at the very end of like the available numbers that you can pick. So we finally end up with a safe range of 0xEO to 0x7E. Actually, this is a 0, not an O. Which, for anyone who likes decimal, is 224 to 2016. So I have 2 custom messages right now, and if I picked any value, the maximum value I can pick is 2047. I could pick any 2 random values in this range, which is surely like 90% of that range, and I would have been completely fine. But it just so happens that one of the 2 that I picked was a bad one. As it happens, the other one that I picked, just by pure chance, happens to be in like an empty spot of the ODrive IDs, so it just happened to be fine. But yeah. But after all of this messing around, I know which IDs I can use, and they're all safe, and I feel a lot more comfortable with this moving forward. I was kind of just like shooting in the dark before, hoping that I was like staying out of the ODrive IDs, but now I actually know for sure, and that's a big relief. However, I still have no idea what was causing the unbalanced phases error. The thing that tipped this off in the first place. I don't know. I have like solved that by, one of them just went away by itself. Like I literally did nothing. And then I did the calibration again, like 10 minutes later, and it was fine. But the other one, I just unplugged it, plugged it into a different ODrive because I wanted to see if the problem was the ODrive or the motor. And so I unplugged it, plugged it into the other, like a neighboring ODrive, ran through the whole sequence, it was fine, plugged it back into the original one, and it was fine again. So, I don't know, maybe there was like dust or something between some of the connectors. I don't know. But it's gone now, so I guess that's good. Yes, John is saying ODrive also reserves IDs for can open messages. Yeah, but I don't really understand what can open is. It seems like it's another protocol that is used commonly in other devices, but I am not currently using any can open devices. Like, I'm just using ODrive and my own custom messages. So I think as long as I'm not using any can open devices, I think I should be fine for not conflicting with that. I don't know. I saw that table. They've got a table on the ODrive docs of like what IDs are fine, and I've been so confused by that. But after all of this like giant snafu, the Oscar on ODrive from ODrive has said that they're going to update the docs and make it a little bit more clear for people who are wanting to do what I'm doing. So hopefully it's a bit more clear in the future. We'll see. Yes. All right. Next up. Yeah, auto leveling done right. And I would like people's feedback on this if you have any. So you may remember I've been having a lot of troubles with this whole auto leveling process, but I'm pretty sure I have done it a not stupid way now, and I'm pretty sure it works. I haven't had the... Oh, what happened to all my windows? Oh no. Somehow I've closed everything. All right, just give me 1 second. Actually, this is a lot faster to open than I thought. All right, that's good. Yeah, somehow... Sorry, that one. Yeah, I haven't had a chance to test this properly yet because I've been too busy mucking around with all of this ODrive CAN problems. But I have tested it like once and it seems to work fine. And I want to run through my logic here. I feel pretty confident about this. So I now have a full separate node that is only responsible for aligning the platform. What happens here is I call a service, I call the auto level platform service, and that starts this whole process where the first thing we do is we log the fact that this process has started, and then we send a command to move to the calibration pose. That just moves the robot up and it sits at the calibration pose, whatever I set that to be. And then we log in within the node that we have initiated the calibration process. And this is important because the next step is we then exit this method. This is important. We have to exit the method. Because the next step is we have a timer that is periodically, every half a second, it's calling this method. Actually, no, let me restep a bit. We've got a subscription to a topic, the target reached topic. And what this is doing is in the CAN bus handler node, the one that's actually responsible for interacting with the ODrives, that is constantly, one of its few jobs, is to look at the commanded position that we have told the ODrives to move to, and then see if we are actually there. And what I mean by actually there is if all of the legs are at the position that they're supposed to be at, and the velocity is 0, like the overall velocity of all of the legs combined. We sum up all of the velocities. If that's close enough to 0, then we say that we're stationary. And so within this platform alignment node, we are subscribing to that target reached topic. So this way, whenever there's a message on the target reached topic, this node will know. And so what this looks like is we basically look in here. I'm transmitting this target reached data as a byte, where each bit of the byte is a small bit of information about what is going on. The first 6 bits are I haven't done a very good job of describing this in the comments here, but the first 6 bits are whether or not each individual leg has reached its destination within some tolerance. The 7th bit is supposed to be for the hand to do the same thing, but I'm not doing anything with that right now, so that's just 0 all the time. And then the last bit is whether or not the sum of the velocities of all of the legs is lower than some threshold. So by looking at all of the first 6 bits, we can see if the legs are at their destination, and then looking at the 7th bit, we can see if we're actually stopped. So this will tell us if this target reached callback gets a message where the first 6 bits and the last bit are all 1s, that means we have reached the target. So we are where we want to be. However, we don't want this we don't want this node to say, hey, we're at the platform calibration pose when we're actually at some other random pose. So that's why at the very, very beginning, we start this leveling initiated flag. And that way we go, okay, we are now leveling. And then next time we get a target reached confirmation that we're actually there, then we know, okay, cool. We are both at the target and the leveling has been initiated. So now we enter this calibrate platform tilt, which is actually called every half a second. But if both of those flags are not true, then we just exit straight away. So every half a second, it just looks at it, goes, no, we are either not at the target or we haven't started initiating, or both, or started leveling. So just exit, just quit. If both of those flags are true and we have started leveling and we are also at the target, then we can calibrate the platform. So we can take a reading from the inclinometer, have a bit of a sleep for a bit, because this node can afford to pause, and then move to the calibration pose. This seems to me like it should work. I have tested it a couple times, but I was having a lot of those random, like, it was moving around problems. So I haven't tested it properly on this system yet, but I'm fairly sure that this works. And it feels a lot more solid to me. The only real things that I'm a little bit unsure of is whether or not I need to have this timer going all the time, or like, it feels like if I could bring this node into life when I want to do the leveling and then kill it afterwards, that seems like it would be the best way, because ideally, I'm only going to be doing this leveling process once per session. So it doesn't really need to be running in the background. And that's why I've got this timer on a half a second, rather than like all of the other timers are like 0.001 seconds. So they happen really, really often. But I don't want this to be taking up too much like compute. So I've just done it as half a second. But yeah, I don't know. It seems like ROS is pretty good at, like, if you have excess topics and excess nodes, then it seems like it's not really that big of an issue. But yeah, I don't know. If you have any thoughts on that, I would love to know. So yeah, this seems good. I feel pretty good about this. I just need to do some testing. However, there's one thing that I would be remiss if I didn't mention regarding leveling, which is something that John pointed out after last week's live stream, which I should have drawn more attention to, but I was a bit caught up in the live streaming moment, which is that really we should only need to do one movement to level the platform. You may remember from last week that I had to go through a whole process where I would go up to the calibration pose. We would take a reading, it would adjust, but it would kind of overcompensate or undercompensate and like not quite get there, but it would get closer. And then we would do that whole process again and again and again. And after like 4 or 5 attempts, it got fairly close to being completely level. We shouldn't need to do that because the inclinometer is extremely accurate and the legs should be fairly accurate at getting to their desired position. So it's a little bit strange that it took more than one iteration. And yeah, this is something I need to investigate. I'm not 100% sure what is going on there. Hopefully it was something to do with the config files or the firmware or something being a little bit messed up in one or more of the ODrives. And hopefully this whole process of like resetting everything and bringing them all back to like a common baseline, hopefully that's fixed things. And yeah, after the live stream today, I want to go through, I need to fix up all of the position gains of most of the ODrives because I still haven't changed them from when they were made negative by my erroneous CAN command. But then I'll give this a go and hopefully it just works, you know? Can't be that hard. Yes. Yes, so my thinking for this auto leveling is to keep it simple, stupid, by separating it into its own node. And yeah, that seems to be making things a bit easier. You'll note that this is not using async IO. I have spent so much time trying to get async IO working. And I think from my like 3 days of trying to get async IO to fit into the ROS node, my understanding now is that async IO is not really natively compatible with ROS 2. And if you want to get it to work in ROS, you can if you know what you're doing. But if you don't know what you're doing, it is a recipe for lots and lots of headaches. And yeah, so I'm pretty keen to stay away from async IO for the time being as much as I can. It seems like if I just code properly, then it's pretty avoidable. And if I allow myself to have more topics and more nodes, then it seems, in this case at least, it completely solved the problem. Yeah, so I don't like async IO. Stresses me out, man. John is saying you should consider using a state machine for the robot, and this would also be useful for the sequence through the leveling. Embedding this in a service that only handles leveling doesn't feel robust. Interesting. I have actually, so I first heard of state machines a little while ago, and I quite like them. I think it was actually in relation to the juggling patterns. There's, let me pull up an image of this. This is a very cool aspect of juggling that probably most people are not familiar with. So there's a thing called state notation in juggling, and you can create these really cool looking diagrams. Come on. Like this. That basically describe, if you are in a given state, where can you go from here? So this whole diagram shows you all moves, all like things that you can possibly do if you are juggling 3 balls and your maximum height is a height 5, which is a fairly high throw, like a 5-ball height throw. This is all of the patterns that you can do, like everywhere that you can go if you have 3 balls and a maximum throw height of 5, which is pretty cool. And this is absolutely what I'm hoping for us to eventually be able to have in Jugglebot, where we can have this big diagram and we can have like an updating, like it will light up with like the state that we're on, and then it will like light up with the path that it's planning to take next. Eventually, will be very, very cool. But yeah, I very much like the idea of having a state machine, and I see the advantage to them. This feels like it's a little bit of a state machine, like it's just its own little isolated thing, because I've got, like within that node, I've got the state of whether leveling has been initiated and then whether we're at the target. That's keeping track of states, but it's a very isolated thing. So it sounds like John, you're suggesting having a bigger one that keeps track of the whole system. But I don't know how to really set that up. Like, what states would this be tracking? Like literally every single state of the entire robot? Maybe. I don't know. I like the idea. If you have suggestions regarding implementation, I'm all ears. Yep. Keeping on. Yeah, Matt's saying I've been working with Python for many years, and I've also avoided async IO. Well, it's good to know that I can keep away from it. You made a comment on Zulip? Yeah, I've been a bit neglectful of Zulip in the last couple of days. I've been trying to focus on fixing these the CAN problems and doing the leveling. I didn't want to distract myself with the leveling, because something that I've been noticing, it's a problem that I did not foresee with respect to like broadening this project out to other people, is that I'm getting a tremendous amount of really, really good feedback, but every now and then, well, fairly often actually, people conflict with each other. Someone suggests one thing and then someone else suggests a completely other thing. And for me, from my perspective, if I don't really know that much about the topic, which is a lot of the topics that we're kind of getting into now, I can't judge which one is like more relevant or more useful. And it's so, I think I've been led astray a few times, not intentionally, absolutely. I do not expect anyone to have intentionally led me astray. I don't think that's been the case. But I think that there are, intricacies with the way that I've set up the rest of my project that make it hard for general comments to really be like super tailored to what I need to do. I don't know. My thoughts on this are very conflicted, but in any event, I felt that I had a good idea of how to do the auto leveling thing, so I just wanted to like shut out Zulip, and I'm like, nah, I'm going to try my thing. I'm going to see if it works. And I feel pretty good about it now. It's actually not what I was thinking, as it happens. I was thinking about using actions, and that, I don't know, I stumbled upon this while I was doing that. So yeah, the TLDR, keep giving feedback. Do not take this as a reason to be like, oh, maybe my feedback's not really relevant. Please do give feedback. If you see something that you think even the smallest amount, you think, maybe that seems a bit weird. I'm gonna withhold because I don't want to confuse him. Don't do that. Give me feedback. Even if it's not super relevant, it's still helpful. It still helps me learn. I've still learned a tremendous amount from all of the feedback that has been not super relevant. There's been a lot of things with like, especially with the linear actuators. So many people have suggested like completely random things with the linear actuators that I'm like, that doesn't really fit at all with what I'm doing, but it's cool and it's useful maybe for something in the future. Yeah. Yes. So yes, I will address Zulip today, hopefully. I think I'll prioritize that over doing the homing, actually, the alignment. Okay, next thing. Now we're getting onto some better stuff, some lighter content. The Bellows saga continues. It never ends. What we want, bellows like this. They compress. Look at how beautiful that is. They fold nicely. It looks great. What we have is either things that don't print properly, or I recently changed the geometry of the print because I'm like, no, this is making me too mad. I'm going to change the geometry and just see if this helps. And I did. And it printed perfectly 2 times. I used different settings both times and it was like easygoing the whole time. No visible issues whatsoever. They look beautiful. But they don't bellows anymore. They don't fold. They fold all wrong. They just crumple up. So frustrating. So these can print, can't bellows. So it seems like there's a very, very fine line between having these bellows be printable and having them actually work as bellows. And if you are curious, then what I changed in the geometry is in the sketch here that's governing everything. I previously was controlling the angle between these 2 lines here, and I set that to 83 degrees because I found in my testing earlier that that worked for like folding as bellows. But that was leading to too steep of an overhang. So I said, okay, that's not good. I'm going to make a maximum overhang of 45 degrees. And that's what we have now. So this is at 45 degrees, prints beautifully, no qualms there, but it doesn't work as a bellows. So I don't know. If you have any thoughts about what might help this, I'm all ears. I have a feeling that, oh, actually one other thing is that I changed this 6. This wasn't 8 before. So I changed like the depth of the folds, if that like the concertina bits. I have a feeling, oh, I don't know. It seems to me like this depth here, like how far in and out those go, that seems fairly important. That angle is obviously very important, but it also feels like maybe the number of in and outs might be relevant here. I don't know. This actually, as an aside, this actually probably would work in my setting because it does still allow, like if I hold the bottom bit here, the top bit can still do the movements that I want it to do, and it resists torsion the way that I want it to resist torsion, but it won't look nice. Like if all of the legs have got this like crumped up mess on the bottom, it's not aesthetically pleasing at all. And to be honest, it actually might even hit the ball joint in the middle and cause issues there. So yeah, if there's anyone who is familiar with how to make bellows, I would love to know. This is, yeah. It feels to me like there's so many geometry things that I could change that I don't really know where to start, and I don't want to really go through the process of like printing off like 1,000 different things to get to the bottom of what's going on. Yep. All right, next thing. We've also done the Regen clamp. Finally, my larger soldering tips arrived, and I got to work and have finally finished the Regen clamp. Look at this. Got a beautiful inlet, beautiful output. Looks pretty neat in there. The only thing that I haven't done yet is that I need to drill the holes in the sides to let the air come back out again. So when the fan pushes the air in, and currently it has nowhere to go, so I need to drill those holes in. But hopefully I'll be getting my drill back today, and I can do that. But I will comment that I kind of regret making this the shape and the size that I did. This, while it looks fairly neat in there, let me see, yeah, like it's pretty good, right? There's clear airflow, like we've got the fan over here that goes straight through over the heat sinks. There's another heat sink over here. It looks pretty good, but my God, was this hard to fit in here. I spent so long trying to just like finagle everything and like make sure all the wires are like just the right length. Yeah, I really should have made this like 10% bigger than I did. There's no reason why this has to be as small as it is. It should have just been bigger. But it's done now, so I don't need to worry about it anymore. However, there is one irk with it, which is that the RTD sensor didn't work. So there's a spot on the ODrive Regen clamp, which is the circuit board that's in here, and that accepts a temperature sensor, basically. And the idea is that you put that temperature sensor on your brake resistors, and then as this unit is working, so the whole purpose of this unit is to dissipate power from the robot when the robot is stopping in aggregate. Like if all of the legs move down really fast and then stop really quickly, that power has to go somewhere. There's a lot of inertia in the system, and that energy needs to go somewhere. It can't go straight back into my power supply because my power supply doesn't like that. So it has to go through this regen clamp, which will dissipate that power as heat through the brake resistors. So the idea is that you put a temperature sensor on your brake resistors, and then you can set a little switch that says the maximum temperature that I'm happy for my brake resistors to reach is whatever it is. And then when, or if the brake resistor hits that temperature, then the regen clamp, I believe it just shuts off. And I'm actually not sure what the end result is, but I believe it stops putting power out, or it does something different. It lets you know that things are hot. And so I would like to have a temperature sensor in here. I don't really anticipate getting to the limits of this. This has the total combined output of 400 watts, like on average. Like what's the like ongoing, like not peak. The peak power is probably a lot higher, but the ongoing power that it's happy with is 400 watts. And because of the fan and because of the giant heat sinks that I've got on there, I feel pretty good about this, that I'm not going to hit the temperature limits. However, it would be good if the temperature sensor was there and working. It'd just be like a nice reassuring, I don't know. I know that I'm not going to break anything in there. However, it didn't work. The plug that the sensor is supposed to go into on the ODrive board is some random ass little plug. So I'm like, all right, I'm just going to take that off and then solder my wires straight onto the board. That ended up being a lot harder than I thought it was going to be. The solder, it just didn't solder properly. I don't know. It was not playing nice at all. And eventually I got the sensor on and I figured I'd give it a test before I pack it all in. And so my plan was to have the sensor off to the side, I'd have the power in, and then I would just hit the sensor with my heat gun until eventually it triggered the temperature fault, and I would know, yep, cool, this seems to be working. However, plug the temperature sensor in, plug the regen clamp into the power, turn it on, and immediately it says temperature sensor, or temperature is over the threshold that you've set, which was 120 degrees, and I didn't have the heat gun on it. It was just sitting in my room. And I'm fairly sure my room is about as far from 120 degrees as you can get. And yeah, so that was definitely wrong. The soldering was all fine, no like cross connections, like, I don't know. I'm not sure what happened there. So I ended up just cutting off the temperature sensor and by this point I'd spent like 4 hours, I think, just soldering and just like standing, like, well, sitting over the thing, just trying to get it all to fit. And I'm like, nah, screw it. No temperature sensor for me. Just cut it off. And now it seems to be working. So yeah, we have no temperature feedback, but that's okay. Because I really don't think we're going to hit the limit on there. Ay. Cool. All right. And the most exciting thing this week, the thing that I have been doing as a bit of procrastination when I've been hitting too many other roadblocks in the other things, is that I got a new camera. Because you may remember in the past, I have been doing a lot of work. Like whenever I'm sitting down with Jugglebot and I've got the camera up in the corner showing, like, coming down on me, if I wanted to show you something in particular, I'd have to stand up, come over to my desk, move the camera around with the little the desktop controller, and then move back and then hope that it was in the right spot. And I was like, oh, I really want a remote to be able to control the camera so that I can do stuff like this and like move it around manually. And it's got like a zoom. You can like see what I'm seeing. This is pretty good, right? So I really wanted a remote so that I could do that, but there's no just remotes available in Australia. You can only buy the remote plus a camera. So I now have another camera. I have two. So we've got this one over here, so we can have a Jugglebot view from this side. I've actually got presets set, so we can go straight to Jugglebot view, and then we can cut to the other camera, and also go Jugglebot view from the other side. How good is that? I don't know why one camera moves faster than the other. I need to, I don't know, do a bit more testing there. But it's pretty good. Like, I really like this. It's very fun to just like play around with all the different settings. Yeah, I'm a big fan. It's really good. Yep, yep, it's very fun. So hopefully this will make for some pretty cool recordings. I think I need to get one more SD card so that I can record from this camera and both of those cameras at the same time. So when we're actually getting Jugglebot moving, I'll be able to like make a really cool video with like cuts between all three different views at the same time, because I'll be recording all of them at the same time. It's gonna be very cool, and I'm glad that this is going well. This is my silver lining of this week. And yeah, my only real question with this is that my lighting setup is next. So right now the lighting in this room isn't really that great, and I want to improve that a bit. I went camping recently and someone had this lighting strip called a Lume Cube that was like a little block like this big, and it was super, super bright. USB-C, wow, looks really cool. I'm thinking of getting those, but like large ones with like a diffuse thing, so that I can put like a large diffuse light next to each camera, and hopefully that will fix the fact that like, I don't know, it's a bit dark, right? Like it's not, I don't know. I think I need to work on like the background a bit to make it a bit more, like to get rid of all these like cables and stuff that are back here. That's a bit distracting. But I think adding a bit more light will be a big improvement. As with most things in this project, this is my first exposure to camera work at all. So if you have any experience with this and have any suggestions, I would love to know. This is obviously fairly aside from Jugglebot stuff, but honestly, I think it's maybe not at least as important, but fairly close to being as important, because if I want to turn this into the job that I want to turn it into, YouTube stuff, I think I need to get my lighting, like I want everything to be as like crisp and good as I possibly can. So yep, I'm all ears. Cool. All right. So that's it for this week. Bit of a frustrating one, but useful in the end. Lots of learning exercises, lots of useful content. Yes, to everyone on Zulip, I apologize for being a bit negligent over the last couple of days. I have been reading your messages, but I've been leaving them on unread so that I make sure that I get back to them later on. For a lot of these messages, they are in domains that I have not a whole lot of understanding. So I've been finding it actually really helpful to, like, when I first see the notification, I'll read through the message, mark it as unread, have it be like processing in the back of my mind for the next couple of days, and then come back to it a couple of days later and go, okay, cool. Now I actually have a bit of an understanding of what you're saying and what I want to say in reply. So yes, I am reading your messages. Don't worry. I'm just busy and slow. Yep. I think that's about it. Cool. Thank you for watching. I hope you found this interesting. As always, good luck with everything you're doing, and I will see you next week. Hopefully with some exciting updates. There will be updates regardless of if they're exciting or not. Hopefully we're nearing the end of the integration hell, but I don't think that's something that you can really predict. So we'll see. All right. Bye-bye.